Hi again, and welcome to another Razorback screencast. I think in this episode we can start to focus on a little bit of UV mapping. That's always been a task that I've found relatively entertaining, because it's kind of like building a puzzle but in reverse, sort of like unfolding an object, and there are always a lot of different approaches. But in this case we're just gonna do it the standard way that I usually tackle it, and let's get started with that. I think I'm just going to group the sky and the floor, hide them for now. And in the Razorback, in the hierarchy, we have these three polygonal objects right here. And for the actual task of UV mapping them, we'll want to leave it as a single-sided object, as in like only exists on one side of the machine. We just want to UV map the side once, and that'll allow us to paint it, but it'll also allow us to easily mirror our work over to the other side. That way we only need to do half as much work. I'll start off by connecting these objects and deleting them. Then I'm just going to copy them outside of the entire hierarchy so we can work on it. So we now have this object, and the first thing I like to do is just inspect the topology, make sure everything looks good, and it does. And before UV mapping, this is kind of our last chance to fix any sort of lingering details or add any more geometry. I always have that moment where I'm wondering if we should add just one more loop of polygons. But in this case, I'm just going to leave it how it is. So UV mapping oftentimes requires sort of a test pattern to get going with. And I do have one of those that I like to use. I'm just going to import it into our file here. So I just drag the texture in, and I do want to copy it to my documents location. And what it gives me here is a new material. And this new material is a 2048 by 2048 sort of test pattern. So if I drag it onto our object, you can see it adds a new texture tag, and it's being applied, but it's kind of warped. The default mapping is spherical. And we can actually go to the editor tab of the material, change the preview size to 2048, so we get sort of a one-to-one relationship in the editor of how much detail we're working with. And once we have this, we can start to play with the mapping. So I go to the texture tool, and we have a sphere of texture right where the center of our object is. Theoretically this could work, but it's not really what we're after. We want to lay this out in our texture view in a much more efficient manner than what's happening right now. So I usually like to use flat mapping as a starting point. It has worked for me, and I like using it. So you can see all of our numbers are backwards. Well, that's our first red flag. We just need to flip things around so all the numbers are forward. Just holding down Shift to quantize that. And now we have something that's a lot more usable. Numbers are forward on the front, backwards on the back. If we look at our texture view, we can see that it's just straight at an angle. If we were to rotate this in a different angle, just for discussion's sake, we look at our texture view, we can see that it's sort of changed. And if we rotate it even more, we look at our texture view. Whoop. No, it hasn't changed. Why hasn't it changed? Maybe it is changing, it's just too subtle for me to realize. No, it's actually not changing. That's interesting. Usually this, there we go. There was just some sort of a delay. You know, oftentimes I find that certain things don't update the way they normally do, and it could be because I'm capturing the screen as I do these recordings. So if I sound like a crazy person, that's why. Okay, so we're back to the flat mapping, And what we can do is just rotate it into place like I had it, 90 degrees. And then we need to select all of the polygons that we want to map. In this case, that'll be all of them. And we have a shortcut here, PA, for assigned UV coordinates. Once we hit that, we get a UV tag, and our texture tag is now sort of in the screen space, or the UV space. So that means that our mapping's stuck. So now if we go to the UV polygons mode, we can see that our object is mapped like this. Right away there's a few problems. You've got overlapping polygons, and the back faces are mapped exactly as the front faces are. So that's usually the first thing I take care of. You know, for a simple object like this, I'm just going to use the live selection tool, and we can just select all of the faces on the inside. Gotta be careful near the edges. And I just want to select the back faces. And the way we're going to think of this is the front faces are actually going to wrap around the sides, but the back faces are going to be separate, sort of separate shells. Think of it as a continuous shell or a continuous piece. You know, lots of software has different terminology for it. I don't remember what Cinema 4D calls it. But now that we have all of these, I'm just going to go to to wireframe mode just to make sure I have all of them selected. Sometimes it's easier to see in this mode. You can see the normals and the outline. It looks good. So now that these are selected, the cool thing is, you know, if we were to drag these around in the viewport, they're connected and we get this ugly stuff happening. But in the UV view, we can just tear them off and they just go their own way. So we can just tear these off, and now they occupy different coordinates. So we can even scale it down a little bit, because there's probably not going to be a lot of detail on the back of these. And we can select all of the other faces, move them over a little bit, and start moving things around. This is where we can start to get creative. So we're just going to put the back sides of them down there. And we can come back here. We can see there's still a problem. The front sides, the numbers are correct, but the back sides, the numbers are backwards. So there's a command. You can mirror U, mirror V to mirror the actual shell. Now these are custom buttons that I've put there, but there are a few different layouts built into Cinema 4D. I'm sure those buttons are in there somewhere. So what I can do is I can just mirror on the U coordinates, and it flips it around. Now they're the right way around on both sides. So that's pretty good. Next thing we need to do is make sure that there's no overlapping. Overlapping is bad because if I were to paint on this part of the object, it would apply to not only the inside part right here, it would apply to here as well. You can see here this pink texture part applying to both of these surfaces, but that's not going to be any good if we're actually texturing that with any intent. So here we move on to the unfolding part. Now the unfolding is it's pretty simple in Cinema 4D. There's a couple tools that make it really easy, and one of them is the pin to border. So there's a relax UV tab here. You can pin to neighbors, pin to borders, pin to point selection, and then there's cut selected edges. So the pin to border is pretty simple. So I have this polygon selected. The regular polygon tools, most of them work in the UV polygon view, so I can actually use my shortcut of UW to select all the connected polygons, and I can move that over a little bit. And so if I were to relax this with pin border points on, all of the points at the outside bounds of this shape are going to stay stuck. Everything else is going to move, but the overall shape of this shouldn't change. When we run it, we can see the overall shape has not changed. Everything else has sort of gotten a little twisted because it's been forced to relax itself within this non-optimal shape. If we go back to our outside view, we can see that that doesn't quite work too well. The numbers get distorted and it's kind of crazy, so that's not what we want. there is a pin to neighbors function. This is easiest to describe if I were to just select just these polygons. What's going to happen is these polygons will be relaxed, but where they meet their neighbors is not going to move. So if I hit this command with pin to neighbors, this edge should stay still, but everything else should flare out a little bit, just like that. So that's not what we want either. But if we use sort of a hybrid approach, and this is what I normally do, it's kind of a trick, we can get it to work. So what I do is I have these three basic shapes. We can sort of emphasize which ones I'm working with by selecting them here in the UV view. And they get selected in the viewport. You can see I'm working with just the front sides and the edges, not the back sides. So there's a few polygons I can spot where the mapping is just perfect. It's exactly the way I want it. Probably it was easier to spot a second ago. Let's see. Probably up here on these, because these are pretty straight on. The mapping seems to be really good. And for this rear part right here, probably these polygons. These two. Well, you know, we only need one. We need one polygon per shell to make this trick work. So now that we have, sometimes you need to click the polygon mode again to refresh this view. So now that we have these three polygons selected, what we really want to do is select everything else, because we want to relax everything else, but leaves these three polygons exactly where they are. They're going to serve as sort of a pinned down point. Picture this is a tarp that's all tangled up on the ground, and you want to straighten it out and lay it out flat in the sun so it can dry. Well, you might have one of your friends stand on a part of it that's already flat, and then have two of your other friends sort of grab all the edges and unfurl it so that it's flat. Well, these selected polygons are kind of like the friend who's standing and putting his weight on it, or if you were to put a rock on the center while you unfold the rest of it. That's kind of what's going to happen here. But we need the inverse of this selection, so I'm just going to press UI to invert the selection. It's difficult to see, but there's no dot in the middle of here, here, or here, because these are deselected. Now, for the time being, we don't want to do anything with this group down here, so we can just deselect those. What we end up with is all the shell polygons on the outside selected except those three faces. Now, if we use the pin to neighbors feature and either LSCM or ABF, either mode would work well. Press apply, they unwrap. And what they've done is they've sort of unwrapped, keeping in mind that these three faces need to be intact. So everything else is sort of merged around it, unfolding itself. And the end result looks pretty good. All of the numbers are relatively free of distortion, and at the edges it wraps around. You can see the edge of the number 5 sort of falling over the edge, but not being distorted. So that's pretty good. There's one other tweak that we can make to make this mapping a little bit better. So you cannot completely unfold an object that exists in 3D, especially an object that is planar with sort of edges like a wall, like this object has. You cannot unfold that without any sort of penalty. And the penalty that we've endured in this case is right here around the edges. These faces are going to get kind of distorted. The inner faces right here are going to suffer because the boundary has to stay still. And you get the same thing up here. Basically, at the corners of the, think of it as if it were a cube and you're unfolding it. You know, some of the corners need to be cut for it to be able to lay flat. So the best way to do that, we can leave all of our polygons selected. The best way to do that is to select some edges. So we find a few edges that are logically corners, for a lack of a better word. So I'm just going to grab these two. This one here is definitely sort of a corner. Now keep in mind, these edges we're selecting will be cut, so don't cut any edges that you plan on painting over, because otherwise you're going to have to paint over a gap. We'll see that in a future screencast. So I'm just going to select a few edges down here where I don't mind cuts happening. It's below, you won't see it, and I really like that area to be unfolded. And I'm not going to do any cuts here because these parts are concave and I'm worried about that. But I will continue to select these edges up here. Okay, now watch how this works. If we look at a part that's kind of stressed, like these parts down here, let's zoom out a little bit so we can see this part up here as well. And we go back to our polygon selection. Notice these three here are still deselected, so we can run this command over and over and it's fine. It's just going to move by just a micro unit as it tries to unfold a little bit more. But in the end, it's going to reach sort of an equilibrium. You can see when I click the button, a dialog box pops up. It's actually a progress bar. But it's going so quickly because this is such a simple object. Now, we selected all those edges. Now we just check the cut selected edges box. And what it's going to do is it's going to split our map everywhere those edges are selected. So we just hit apply again, and it unfolds further. Now, I'm gonna undo and redo here a few times. And notice how the overall tension is sort of being released because the edges are now cut. But also notice now that you won't be able to paint smoothly from one edge to the other. So you kind of have to give a little, take a little in terms of how liberally you use that feature. But yeah, this is unfolded really nicely now. So I'm just going to select the connected edges right here, rotate it a little bit, and sort of pack them a little bit tighter. And now we have one side of it unfolded. It's probably a good time to unfold the inside part, and it's also a good example of why we pinned the points, why we pinned to the neighbors. I'm going to turn off the pin to neighbors and turn off the cut selected edges feature. And let's just relax this, see what happens. So that worked pretty well. Let's try this one here. That also worked pretty well. What can happen sometimes, especially if, let me see if I can create a non-ideal situation, especially if the UV is flipped, maybe? I've seen this happen. Well, this is being very well behaved, but oftentimes when you have a group of polygons that are sort of twisted in a not ideal configuration, and you use one of these relax methods, it may end up, let me try to illustrate this, rotating the object and scaling it down so it's much smaller. And that's oftentimes not what we want because it changes the relative scale of the parts. And when you pin it to border points, pin it to its neighbors, sorry, you get a much better result because there's some sort of frame of reference. At least some part of the object is stable and will not move. So as I pin to neighbors and apply the relaxing, you can see for the most part everything kind of stayed the way it should have stayed. And because these shells here are quite flat, they don't have any edges like the other shell did, they're just fine. We don't need to cut any edges. We can just leave them as is. So the final part of this little screencast is actually going to be the mirroring of these components. So now that we have all of our shells sorted out and they're all the right way around, they're sort of scaled relatively, we like it. What we can do is we can now make this object whole, and then we'll see how we deal with the other half. So we have half of the object here from the top view. And if in polygon mode, we select all the polygons, and then we can use the mirror function, so MH. And there are a few different options. You can mirror by screen, where you actually interactively drag a line, and it uses that as its mirror plane. You can do object coordinates, world coordinates. So let's do world coordinates, because I know for a fact that this object is aligned with the world center Z. So if I go to world coordinates and I change the mirror plane to ZY, so just to give you a frame of reference, if you look down here in the corner, YZ or ZY is sort of the axis that runs centrally in this direction. So that's what we want. And it's going to weld the points. So these points right here, they're going to be welded with a tolerance of 0.004. And then we can just apply it. So now what we have is let's just grab one of these edges to double check. Yep, it's welded in the center. And we now have the UVs duplicated. Notice that it duplicated and flipped all of the UVs. So that's good, we want that. Now with all these polygons on the new side still selected, we can come up here to the UV view and move them away. So this group of polygons represents the new side. This group represents the old side. Now the new side is flipped, as we can see. So the first thing we do is we mirror U, so now the new side is not flipped. The next thing we do is we move it, so you can see here I'm just sort of trying to line up the seam right here. So these two shells meet, and the seam where they meet is sort of right here at the front of the machine. So I'm going to try to turn that back into a seamless structure. And I'm going to select these polygons down here, do the same thing here, and using a tip that I was actually taught by some of my YouTube commenters, we're going to use the UV terrace command to join those back. So, you know, these edges aren't actually touching, they're kind of overlapping up here, but what we can do is go to the UV points mode, get our rectangular selection tool, and sort of select all the points as if this were a zipper. And then we can just select UV terrace and it zips it right up. It just joins all those points together, just like a zipper. And so we can do the same thing down here and run the UV terrace command, zips it up. Now there is going to be a little bit of distortion where we did that because, I mean, we stretched these points and polygons and edges in a way that was kind of unnatural. They weren't exactly lining up straight, yet we stitched them together, so there's a bit of stretching happening. You can even that out by doing a sort of a two-step process. First thing you do is you select polygons sort of bordering on the area you just modified, and you relax it with pin to neighbors checked. See, it's sort of relaxed and it's now a lot more non-distorted. And then you just select everything else. Now of course I've selected a bit too much, but the idea is that you select everything else and then you relax that. But I don't want to do this right now because it'll take me too long to select everything while I am recording. So I'm just going to select this region right here, relax it, reduces the distortion a little bit. It's hard to see because this is quite a distorted place in the first place. But now we basically have, we have the ability to paint straight from this side all the way across the front of the machine, up the other side, and paint graphics everywhere. So the final thing we're going to look at is the command that allows you to sort of pack these UVs in. And before I run that, I'm going to take these UVs, which are the inside part, just move it away. Then I'm going to take these UVs, which are the outside shells, and we go to optimal mapping, and we just have it set to realign. Preserve orientation, make sure it doesn't get rotated very much. Equalize island size. I believe that means that they're going to be the same size relative to each other. We can test that if we want. And there's a spacing factor. 5% should be fine. So we just hit apply and it sort of packs them in as tightly as it can. So if we change the spacing down to 2%, things get a little tighter. 3%, a little more breathing room. 5% is fine. You don't want these too close. So now that we have this, we have the ability to sort of pack everything in a lot more tightly, use the space a lot better. But you know, it is a computer sort of blindly doing it, so maybe it didn't do the best job in the world, so we can come in here and sort of pack these in a little bit better using sort of a human touch. Just kind of like that. Like that makes a little bit more logical sense to me. I understand why I'd put these up here and these down here, because it's just better use of the space. But we can make those kinds of decisions as well. Oh, before we get any further, let's test that equalize island size feature. So if I made this one really big, and then I selected these and said pack them again, yeah, so it makes it the correct size relative to the real size of the polygon objects here in the viewport. And now that we have these packed in, remember these shells down here are the back side of the object. We don't really care very much about the proportional size of those or how much texture space we get for them. Well, I don't, you might. And so what we can do, what I usually do, is you just fit this in the space that's left over. These do not need to house a lot of detail. It doesn't really matter what they look like. It kind of matters, but they're going to be hidden for the most part. Usually I just color them black anyway, and they just sort of lurk in the shadows. But you know, you can just pack these in wherever they'll fit. It looks like I can put a piece of one up here and then try to pack this one in down here, and there we go. We sort of made it so it fits. And so there we have it. We have a completely UV mapped object, no overlapping points or polygons. All of the numbers on the test pattern are correct. None of them are backwards, I think. Yep, that's a 5, 7, 8, 9, 3. So yeah, now we have our fully UV mapped armor, and it doesn't need to be an asymmetry object anymore. And so we can just rename this armor, and we can turn our Razorback back on, and we now have our armor UV mapped, which means we can now put scratches and a base texture, make it look kind of grungy, kind of used, and you know, that was a pretty fun object to UV map. So I hope you guys enjoyed that, and until next time, see you.